6.4.4 Solve square root equations for extraneous solutions. Essential question. How and when do I need to check for extraneous solutions? Skill. I can solve square root equations. A square root equation is given below. X plus 1 equals the square root of 2x minus 3 minus 4. First thing you want to do is isolate the square root, so let's subtract 4 from each side. From there, we're going to get rid of the square root by exponentiating by 2. Let's expand the x minus 3. From there, we can use box or FOIL to multiply these out. Let's just use FOIL today. We have x squared minus 3x minus 3x plus 9. Okay, let's move everything to one side of the equation. And then we have x squared minus 8x plus 12 equals 0. Let's factor this. We will find two numbers that multiply give you 12, and they add to give you negative 8. We know they both have to be negative in that case. So we have 1 and 12, 2 and 6, and then 3 and 4. Negative 13, negative 8, and negative 7. So we want to use these ones. So we have x minus 6 and x minus 2 equals 0. Set each of those equal to 0 separately and solve for the two x's. So x either equals 6 or x equals 2. Now, it might not be both of these. You're going to check for extraneous solutions. You want to check for extraneous solutions when there is an x on the outside the root. You only need to check for extraneous solutions where there's an x on the outside of that root, that square root. Otherwise, you won't need to check for those. Let's check when x is 6. So plug in 6 into the original equation to see if it's true or not. So is 7 equal to the square root of 12 minus 3 plus 4? Well, as the square root of 9 plus 4, that equals 3 plus 4. That equals 7. So that one works. This was a real solution. Now let's check 2. 2 plus 1, is that equal to the square root of 2 times 2 minus 3 plus 4? Is 3 equal to the square root of 4 minus 3 plus 4? 3 equals square root of 1 plus 4. No, 3 does not equal 5, so that is extraneous. So this was real, this was extraneous. Okay, try the other examples below.